Small-scale miners and prospectors, novice gold seekers included, will at some point in time will need to know what you may be sitting on. For a minority of prospectors, we not only seek the precious and noble metals, we also look for industrial metals as well. Novice individuals are those that are recreational panners that become interested in the mining aspects and either start prospecting or they may be looking at buying a claim. Miners, for many reasons, may be wanting to sell their claims. In regards to the latter, these prospects will need to be proven. Just because you found gold does not mean that it will be profitable or even viable as a hobby. Gold deposits are subject to the nugget effect. This means that the gold is found as pockets of material. These pockets may be large in size, such as gold-bearing veins running through hard rock and faults, or they may be placer in nature. The fact is that these pockets may and most often are isolated and very small in size. One could be throwing good money into the wind. This is where statistics becomes a necessary tool regarding the buying, the selling, or for completing the process of doing a claim acquisition. This series has been redesigned for the small-scale miner or prospector, as well as the novel individual, and is not focused on the professional assayer. This is for the average individual that is not familiar with or has not taken an educational course on statistics. I am Rob Boyko, Boyko Mineral Exploration, and welcome to this new series titled The Secrets of the Gaussian. This is part 1, the histogram. The table is a grid sampling pattern that was conducted on one of my claims. This was and is being done for statistical analysis for 3 industrial metals. So let's focus on the class table. It is the start or the beginning of the formation of a histogram. The values are hypothetical, but does represent what could be factual. The data presented is what would have been recorded from accumulated field samples. This could represent aluminum concentration within each sample in percentage. There's not much data shown, and in retrospect does not really tell you much other than there is aluminum in the sample base, which requires further analysis. In essence, more data means more sampling. To start, a class table needs to be created. It can be done in many ways, however, data is limited, therefore the data is broken into ranges of data as shown. All tables are built on frequency. That is to say, how many times does a similar value appear in the data set? It becomes easier to determine when the data set is arranged from the smallest to the largest value as shown. As you can see, there has been 5 pieces of data that was in the range of 2.3% and 2.4%. Each range is given a bin number. Think of the bin as being a container which holds all the values in the specified range. With this information, the histogram can now be constructed. This is the completed vertical bar histogram as a result stemming from the previous shown data table. The frequency table. As you can see, it does not tell you much. I placed the black vertical lines as well as 2 red lines in the end segments to show that the table is rather limited in useful information. This graph only tells you that you had, for example, 5 samples showing a concentration of aluminum between 2.36 and 2.4%. Even though I added the concentration segment of 2.36, 2.38, and 2.4%, it does not tell you how many entries were at that percentage. It does not tell you that you had 3 entries showing 2.38%. It could have only been 1 sample having a concentration of 2.38%. I would not be purchasing a claim or investing in registering a claim on a graph as shown. It is not even close to giving an accurate estimate of what you may be considering as viable. On the left or y-axis is your bin numbers. These represent the amount of data entries that have concentration in the ranges specified in the frequency table. On this graph, they are listed as number of samples. Now the x-axis shows the concentration of the samples. The width or range between the lowest concentration and the highest concentration is known as the class width. The class width refers to the range of the recorded values that are used to create the frequency table in label segments on a graph. These represent the concentration values within the graph along the x-axis. These labeled indicators are spaced apart at calculated intervals. In this graph, the labels are spaced every 0.04%. They could have been spaced at intervals of 0.05%. The information would have been the same. There are a few formulas that are used to calculate the class width, and some are quite complicated. To keep it simple, the most widely used equation is shown. K, which means class width, is simply calculated by subtracting the lowest recorded value from the highest recorded value and dividing by the number of bins that were created for the frequency table. The result is 0.05. Well, therefore, I chose the starting point at 2.0 and added the labels every 0.04 points on the x-axis. Using the formula shown, it should have been every 0.05 points instead. The graph is still correct, and here's why. Microsoft Excel has a function to be able to create graphs. There are tutorials online that explain how it is done. However, a computer may not have the software, or a computer may not be available. The formula that Microsoft uses for this purpose is shown. It is simply the square root of the number of entries used in the table. I used this formula for the example. The value of 4 means that a division of 4 spaces will be used between labels. Since the number of decimal points is 2, the division would still be 0.04 or 2.0 to 2.04 to 2.08 and so on. In statistical analysis, it has always been said and taught that the larger the sample or the greater the number of samples will result in a more accurate estimate. Well, it does. Let's beef up our examples a bit. Say we had 123 gold pans, and we recorded the amount of gold obtained from each pan. The weight of concentrate per pan prior to panning would have to be weighed. More on that later. The point is that we have a lot more data in these tables. The table on the right is the same table as the left, but it's sorted. We can now start to build the frequency table. The frequency table shown is the result stemming from the 123 gold pans. Notice the class column being the bin values. There are 10 bins. If you look closely, you will notice that the bins are constructed from the recorded grams from each of the 123 gold pans. The bin number is the frequency of the reported grams. That is, the number of times that the gram weight was recorded initially in the sampling table from the previous slide. The class width could be determined using either formula. 0.002 will be used as it gives a much greater scale to work with. 0.004 could still be used, but will tend to add a small amount of confusion when trying to read each concentration point value on the x-axis. As you can visualize, we have a lot more information now. We now have some specifics. If I wanted to know how many gold pans that I had that contained 0.222 grams of gold, just by looking at the chart I can say that I had 10 pans. You should now be able to understand why the more data you have, the more accurate. Instead of saying that I had 30 pans that had a range of 0.220 and 0.222 grams, I can now be more accurate and say that I had 10 pans containing 0.222 grams of gold, 10 pans containing 0.221 grams of gold, and 10 pans containing 0.220 grams of gold. In total, I ended up with 6.33 grams of gold from 30 pans of concentrate. Would I invest good money on a claim like this? Well, not quite yet. The red plotted lines are the result of the data set and the frequency table. However, I drew in the blue line. Notice how it started to form a nice bell shape. This graph definitely points out the fact that the more data you have plotted, the more accurate will be the results. If more data was added to this chart, that blue line would start to expand and change shape. It would start to look more like a bell, hence the term bell curve or Gaussian. In this presentation, part 1 of the secrets of the Gaussian, I introduced the basics of the histogram. I hope that I presented this in a way that the average person that has not taken any courses on statistics could understand the foundation, that is, the starting point of statistical analysis, without going into a lot of theoretical discussion. This edited video presentation was specifically designed for the small-scale miner, prospector, or novice panner. In part 2, I will be discussing the different curves regarding some of the charts that you can produce and how they may fit into your operation. As well, I will be expanding on the bell curve. I am Rob Boyko, Boyko Mineral Exploration, and I thank you for watching.